Here are your video notes for lesson 5.2. Remember, if I'm writing something down, you should be writing it down too. The title of lesson 5.2 is Parallel and Perpendicular Lines. Need to define for you what are perpendicular and parallel lines. I'm going to do perpendicular first. And perpendicular lines are lines that cross and form 90-degree angles. So an example of this would be here's a line, those lines are crossing, there's where they intersect, and they form a 90-degree angle, and actually they form four 90-degree angles. Parallel lines are two lines that never cross. And the fancy word for never crossing is that they never intersect. So an example of parallel lines would be here and here. The other special thing about those lines is they have to lie in the same plane or the same flat surface to be parallel lines. Perpendicular has a symbol that gets used for it, which if you want to write it next to the word back here, that's the symbol for perpendicular. I usually think of it as it's an upside down T, and that red part right there shows the 90-degree angle, but that red is not drawn in. Parallel lines have the symbol that just look like two. I want to get rid of it being in red. Let me switch back to black. And two parallel lines, it looks like the number 11, but usually be drawn a little bit bigger than things. I'm going to put parentheses around those as far as the symbols. If you commonly get the words parallel and perpendicular mixed up, I would encourage you to just look at the word parallel and see that there's two L's here, and the two L's drawn properly actually show two parallel lines, or give an example of parallel lines. Another word that we want to get defined for you here is a transversal. A transversal is simply a line that intersects forgot my T there. Forgot a lot in spelling that word. Intersects two or more parallel, and I'll use the symbol for parallel right there, intersects two or more parallel lines. So if we draw in another line in our parallel lines, and we draw it in so it goes across, the transversal is that line right there. And if we move forward, we're going to define some angles that now result when you have two parallel lines that get cut by a transverse or transversal. I'm going to try to fit this up here kind of small so I have room to draw or list some things down below. If you'd please try to get two parallel lines drawn so they're parallel like that, and let's have the transversal go right straight across right here. We could say that this is line M, this is line N. M and N are parallel lines, and let's call this line T just so it sounds like transversal. A lot of times you'll see that the book would put something like this next to it and let you know lines M and N not only look parallel, but they're supposed to be exactly parallel. When you do this, you end up with 8 angles. Angle 1, angle 2, angle 3, angle 4, angle 5, angle 6, angle 7, and angle 8. If you number your angles off as I've done, we could go through, and we already know some of these angles are congruent from what we learned yesterday. So we're really looking for congruent. I spelled congruent wrong. Congruent angle pairs. And we will give them names as far as the special kinds that you see. You should already know we have vertical angles will always be congruent, and the pairs of angles that are vertical angles here, you should see angle 1 is a vertical angle with 6. So we could write angle 1 is congruent. That symbol here means congruent if you want to get that written in up there too. Angle 1 is congruent with angle 6 because they are vertical angles. We could go and we could say angle 5 and angle 2 are also congruent. Angle 2 is congruent to angle 5 because they are vertical angles. We can go on looking, we can find more. We can find angle 3 is congruent to angle 8. And we could also find, running out of colors here, let's go back to black, angle 7 and angle 4 are congruent because those are all vertical angles. A new type of angle pair, and as you can see I also cleaned my drawing up above, but a new type of angle pair that you're going to end up encountering or have to know the name of in the future is corresponding angles. And they will be pairs of angles that actually will if you look at the points of intersection, they go off in the same direction from this point of intersection. Like angle 1 goes off to the left and is up. Angle 3 goes off to the left and is up. They are going to be congruent angles when you have parallel lines cut by a transverse. So we could list those off as being angle 1 and, whoops, let's not put the word and. Let's say angle 1 is congruent to angle 3 because they are corresponding. Now you guys won't want to keep doing all this on your drawing because I'm just going to erase them. So don't draw those in. But if we keep going on around, we should end up being able to find 4 pair of corresponding angles. Angle 2 goes up and to the right, as does 4. So angle 2 and angle 4. I didn't want to use the symbol for and again. There I wanted to put in congruent. Angle 2 is congruent to angle 4. If we switch colors again, let's go green. If we go down and to the left and down and to the left, we would see angle 5 is congruent to angle 7. And if I go back and look at going down and to the right, we're going to get angle 6 and angle 8. So angle 6 is congruent to angle 8, and these are all examples of corresponding angles. I've cleaned my drawing up again, and we will go on and we will define for you what are alternate, exterior, whoops, not alternate exterior, let's first do alternate interior. I think these are a little easier to understand. Angles. And you'll want to probably learn to abbreviate these. I would abbreviate them as AIA for alternate interior angles. Alternate's going to refer to that we are going to switch sides of the transversal. So if one angle is on top, the other angle would be below. So do you see an angle below the transversal that would be the same size as angle 2? And the one I would want you to pick out right now is angle 7. They are on switching sides of the transversal. But the key thing here is that they are also, the word interior is actually referring to, grabbed the wrong thing there, the word interior is actually referring to being inside of the parallel lines. So 2 and 7 are congruent angles because they are what are called alternate interior angles. I have the wrong drawing tool. Angle 2 and angle 7, and there's another pair, and that would be angle 6 is on the interior along with angle 3. So angle 6 is congruent to angle 3. Pen's not writing correctly right now. Okay, I've cleaned my drawing up again now so that I can define for you alternate exterior angles. And if you want to be able to abbreviate this, it's AEA for alternate exterior angles. And now you might be able to recognize we are not going to be concerned with what's inside the parallel lines, but instead what's outside the parallel lines, which would be this area is outside and this area is outside. And once again, we're talking about angles that alternate. Angle 1 is above, the parallel line or the transverse, and angle 8's below. They're the same size. They are an example of alternate exterior angles. So angle 1 is congruent to angle 8, and we'll get one more pair of that. If we look, we also have angle 5 is out exterior angle, and if you alternate to the other side of the transversal at the other side of the parallel lines, we get angle 5 and angle 4. Are alternate exterior angles. Alright, so how are we ever going to use this information? And let's put the parallel lines going straight across this time. Let's call that line A. Jump down a couple of lines, call this line B. We'll have a transverse cut through that way. We'll call that line C. We'll write over here then that we know line A is parallel to line B. I'm going to go through, change colors. We have angle 1, 2, angle 3 and 4, 5 and 6 are now down here, and 7 and 8 are at the bottom. What are we ever going to use this for? We are going to be able to determine the size of all those angles if we only know the size of one. So right now, if we were told that the measure of angle 2 is 60 degrees, we should be able to conclude then that the measure of angle 2 would be equal to the measure of angle 3, because 2 and 3 are vertical angles, and we should also be able to include that this would be equal to the measure of angle 6, because angle 2 and 6 are corresponding angles, and if 6 is equal, then it's got to be equal to 3 because they're alternate interior angles, and 6 has to be equal to 7 because 7 and 6 are also vertical angles. So the measure of angle 7 is equal to that. And not only that, we know the measure of angle 2 here has to equal the measure of angle 7 because they're alternate exterior angles and therefore are congruent. So all of those angles are 60 degrees. Now, is there a way that we could come up with how big are the other angles? Well, if we know that this is 60 degrees over here from the day before, lesson 5.1, what kind of angle is this that forms this straight line? And I hope you recognize that as straight line's got to be 180 degrees. So angles 1 and 2 are actually supplementary, which means they have to add up to 180. 180 minus the 60 degrees already there, that means that this side has to be 120. So we now know the measure of angle 1 is 120 degrees, and we should know that the measure of angle 1 has to equal the measure of angle 4 because they are vertical angles. The measure of angle 5 has to be equal to the measure of angle 4 because these are alternate interior angles. plus angle 5 and angle 1 are corresponding angles. Angle 5 and angle 8 are also vertical angles, so they have to be equal. The measure of angle 5 has to equal the angle of 8, plus angle 8 and angle 1 are alternate exterior angles. All of those angles have to equal 120 degrees. So that's using the relationships that develop from those angle names, and that concludes our video notes.